The Planck space fluid hypothesis. Hypothesis. The Planck units represent the quantum properties of a space fluid, which is the maximum density counterpart to the minimum density vacuum space fluid. Both Planck and vacuum space fluids are spatially flat, isotropic, and homogeneous. Both space fluids obey the ideal gas equation of state and have the same value of unity for the equation of state parameter. Both space fluids have the same permittivity. The maximum values as well as the minimum values for quanta in nature are represented by space fluid quanta. The Planck space fluid hypothesis. Possible implications for cosmology. If the Planck space fluid hypothesis is correct, then two first-level conjectures are immediately suggested. Conjecture 1 Level 1. A Planck space fluid defines the initial state of a universe system. Conjecture 2 Level 1. A Planck space fluid would form the core of a black hole. The flat, homogeneous, and isotropic nature of the Planck space fluid suggests a simple model that allows for an inflation-free expansion of the universe, as described by the second level of Conjecture 1. Conjecture 1 Level 2. The Big Bang would represent the equilibrium and adiabatic, unmixing, of the Planck space fluid into two flat, homogeneous, and isotropic radiation fluids, consisting of nearly equal numbers of gravitons and grand unified bosons. The version of the Big Bang in Conjecture 1 Level 2 describes the origin of the cosmic backgrounds for electromagnetic and gravitational radiation. This picture of the Big Bang suggests a third-level conjecture. Conjecture 1 Level 3. Incomplete reaction of the Planck space fluid in the Big Bang might seed the early universe with primordial black holes. This conjecture might explain the origin of dark matter. Primordial black holes might solve a problem of supermassive black hole mergers called the last parsec problem. Primordial black holes might play a key role in the direct gravitational collapse of giant gas clouds into black holes in the early universe. A second-level conjecture that follows from Conjecture 2 Level 1 is that Conjecture 2 Level 2, the Planck space fluid core in a black hole would generate radiation and high-energy virtual particles with mass in the vacuum region surrounding the core surface. The radiation and matter particles are produced by quantum mechanical processes. These processes explain Hawking radiation in the vacuum above the event horizon and the production of virtual particles with mass inside the proton and in high-energy particle beam experiments. This internal radiation energy would allow the core to grow without any source of energy from outside the event horizon. This behavior of black holes may have recently been observed. It has been called cosmological coupling, where black holes seem to grow with the expansion of the universe without external energy inputs. Either the black hole core mass would increase indefinitely in this way, or, more likely, Conjecture 2 Level 3, consumption of the near-core radiation energy by the Planck space fluid allows the core to grow to a maximum mass and size. The maximum mass of the core could be the result of a simple mechanical stability limit, e.g., a maximum angular momentum. A maximum mass for the core seems even more plausible when partnered with the fourth-level conjecture that Conjecture 2 Level 4, this maximum mass for the black hole core fluid would occur at the Big Bang, or initial time for a new universe. Conjecture 2 Levels 2, 3, and 4 provide a physical connection between conjectures 1 and 2 of Level 1. This set of three conjectures ties together the two first-level conjectures by suggesting that the Planck fluid formed in a black hole core eventually defines the initial conditions at the Big Bang for a new universe system. Implications for the multiverse. A multiverse of independently created, parallel universes is predicted by Conjecture 2 Levels 2, 3, and 4. These three conjectures describe the Big Bang and its relation to black holes with Planck fluid cores, i.e., conjectures 1 and 2 of level 1. A major prediction of the present model is that the fundamental constants in all parallel universe systems of the multiverse would be the same because they are defined by the Planck fluid quantum properties. A constant amount of homogeneous, isotropic, and flat Planck fluid would represent the initial state of all universe systems. This method of universe system self-replication could lead to the same history for the thermodynamic properties of the cosmological fluids, as well as the same history for the fundamental particles in all the parallel universes in the multiverse. Hence, the cosmological principle applies to all parallel universes. The picture of the multiverse in the study differs from that of Everett in that the universes of the multiverse are independently created and are not the result of splitting of the wave function. The Planck fluid acts like the DNA for a universe system. The maximum mass Planck core star, a type of black hole, acts like a universe seed. Each universe, in turn, acts like a seed for a new part of the multiverse. The above conjectures describe the broad outlines of the quantized space fluid cosmological model. The author feels that the physics of the QCEF cosmological model is more familiar, natural, and predictive than that of any of the existing cosmological models, such as the cyclical conformable cosmology, the ekpyrotic model, as well as the Big Bounce and Big Crunch cosmologies.